Welcome everyone to ElmerBench episode number 2. Jim, NO1PC here. What we have before us is a build project. Yes, we're going to build, solder, cut holes in metal, and create a slight monstrosity. Well, not really much. The idea is to compact all this stuff into a single, more simplified wiring version of an all-star node to interface with a radio system to create a repeater or just a standalone node. There are various ways of doing this with Pi hats that integrate some of the electronics onto a board that integrates with the Raspberry Pi, external interfaces, sound card fobs, all that nature. But we've got a little different picture to show here. So nothing unusual, just an interesting packaging process here. What we have is Raspberry Pi 3 Plus and a generic case for it, just to keep the dust and whatever else out of it. We'll be putting it in the chassis and integrating it with a Kevin Custer repeater builder RA40 interface, and we'll see if we can get some focus on this little gem here. Let's see how this works out. It's hard to shoot these things and look at them in the camera and make sure everything's right. But that's how we roll. So the RA40 interface has got a DB9 with all the attendant radio signals, receive audio, transmit audio. It will bring out a CO or accept a CSS PLD code signal, push to talk, transmit audio into the traditional CM109 sound card chip with a little audio processing, which helps us out here. We've got some level controls. That's a good thing. And ultimately out to the USB interface to the Raspberry Pi for configuration with either the two All-Star simple USB or radio USB processes. So we'll work on that. That's pretty well covered in other videos and discussion about how to control what's going on here. This build may or may not end up talking to a repeater controller out of the radio interface, or standalone be the actual repeater. We have one of these builds in its first generation as an active repeater site, with the Pi and All-Star acting as a repeater controller at a site here in Northern California, and it has just been stellar. It just sits there and runs, and it's working pretty well. The challenges with dealing with the Pi and dealing with the radio interface are getting power into it and the form factor interface of the Pi itself. This is not an industrial design optimized for packaging and cable management, having I/O coming out of three sides of the device. That's a little bit cumbersome, and we may have some workarounds for that. We'll explore in this build. Some of the physical challenges are getting the 5-volt power into the Pi, which is traditionally done by micro USB. There is a way to get around that. Involves a little delicate soldering. We'll cover that. The other issue is having an adequate 5-volt supply for the Pi, which demands 2.5 amps or greater, and there are a couple of ways to do that. A PowerWorks USB buddy does a very good job of that, but it's got this big huge connector to get from there to this little guy. I think we can work around that. For one thing, there are some aftermarket things available on Amazon, eBay. We may build this into the box and test that out and wire around that aspect. The other very cumbersome thing about the Pi and most radio interfaces is either having a sound dongle coming out of the USB port, or in this case having this USB connector go to another USB connector. We can probably wire around some of that. I've done this before, a couple of creative ideas on how to get around that issue, and so that's part of the process here. We'll work through, plus or minus all the metal chips and soldering. So I hope you're not afraid of soldering and melting things, because that's what's going to happen on camera or as a result. But we'll try and do it on camera because people seem to like that stuff. And there are ways to get to the power terminals here. We'll deal with that. There are ways to get to the USB interface here without the connector, so we'll deal with that. What we're looking at here is taking an LMB box, and I need to go back and find the model number for this. It used to be an $8 box, it's now a $12 box, available at common sources, probably Mauser, DigiKey, other online sources to get this box. So what we're going to do is we're going to package this set of boards into the aluminum chassis, accommodate the holes so we can get to video for local configuration, provide for the Ethernet connection and USB out one side. You can see all the little blue scratches. Most of that sheet metal is going to go away to accommodate that, and to accommodate the radio interface in such a way that it's a very solid construct. So we have a virtual Pi hat kind of thing going on here. We have enough room in here to work out one of the DC to 5 volt converters. We'll see how that works out, getting that in the box. It's going to involve some drilling, a little bit of brute force nibbling. This is a Dell nibbling tool, which has been around for, I'm thinking, 30 or 40 years. It's very handy to get in there and make square surfaces or square cuts, which we've marked out here. So all the blue scratch marks are going to disappear and become holes for access for the Pi, for the radio interface, for the HDMI and the micro USB. Hopefully we can eliminate those eventually in going forward builds. So we'll end up with these two boards coming together and creating a pretty nifty little tight chassis that is a unified node with the only 2 or 3 signals we need is something from Wi-Fi to connect to the internet to put the node on the net, the radio interface, which will be provided by the DB9 connection, and power. Who doesn't have 12 volts or 12 volt radio around somewhere? So we'll try and figure out how to bring that out. I don't have any chassis mount Anderson power pole connections, so that may be a dangler until we refine that and find room on here to facilitate that in the chassis. I'll spare you the drilling and the metal bits and a couple of things. May show the application of the nibbling tool, very handy thing. File to get rid of the sharp edges so you don't draw blood in this process. That's not required in most ham builds. So that's our goal here, is to bring these pieces together into a very streamlined, compact. Shielding is optional. Radio interface for your garage, for your den, for a repeater site. Again, we have one of these builds in generation 1 is the repeater control and linking interface for one of our CalNet systems here in Northern California, and it's just sat there and run all the time. No RF issues. It's a very low RF site. We have looser interfaces going on higher RF sites, so I'm not too worried about the Pi or the interface being RF sensitive. But this is just kind of a good in the shop process to go through to chew up some metal, melt some solder, hopefully not burning any insulation, and get us a node on the air. So that's the raw material part of the project, and off camera I'll do some of the drilling and punching, little center punching. One of the aspects of getting this nibbling tool to work is it's going to take some 1/2-inch holes to get the nibbling tool in there so we can square these off. If I had a milling machine, I would probably dig in there and and be real custom about the HDMI and the USB and those kinds of things. But we got what we got. I think anybody can do this in their home shop, and you'll end up with a cute little aluminum box with a node for whatever purpose you want to put it to. So there's our intro to this project. Off camera again, I'll do the punching and drilling, and maybe do some demo of the nibbling tool, which I'm not sure many people have heard of this, but it's been a childhood toy of many of us hams, and very handy for various chassis projects. So there you go. We'll see as holes get created, and we start mounting this thing up, and there will be some solder melting. And we'll try and zoom in on some of the connection bits and pieces, where to connect the wires. I don't think it's novel, but an example of how you can cheat around these huge connections just to get some signal in and out of a card. Thanks for watching for this part of it. We'll meld this into the whole build as we go along, but here's a teaser, and best 73s. And on one PC out.